Hello everybody. Today in this video, I will talk about this question again. So again, what I mean is, in my last video, I solved this question, minimum cost to hire K workers, and it ended with time limit exceeded. So this time, I will optimize my solution, which I implemented in my last video, this one, so that my implementation will be accepted. Okay, so that being said, let me get started with the explanation. So firstly, I will quickly talk about this question. Yeah. So this is a question to hire K workers. So I will be given the list of workers. There are N workers. And for each worker, I will be given the quality, which is kind of skill, score, and also wage. And wage is the expected salary from that worker. And those being given, I will try to find K workers under some constraint. So I have to decide the salary proportional to the quality of each worker. And I have to, yeah. So that's the condition. So if there is a worker whose quality is twice as much as other worker, let's say worker X and Y, then worker X has to be paid and we have to offer the salary twice as much as worker Y. So that's the constraint. And that being said, with that constraint, I will pick K workers whose total salary offer will be the minimum. And I will return the total, minimum of that total minimum offer. So that's what I have to do in this question. Okay, now and I will talk about my Rust implementation. So in my Rust implementation, I use the max heap of size k. So it went like this. So firstly, I pick one worker, like X. Then I will calculate the wage per quality, which suggests how much money I should offer per one quality unit. Then I will apply that rate to all the other remaining workers. And with that calculation, the offer salary for other workers will be determined. And out of those n-1 workers, I will pick up K workers whose offered salary is the minimum. I have to find mini K here. Then I guess the total offered salary amount with that rate. And I will do that calculation for each worker aside from X. Then I will calculate the total minimum offered salary for each case. Then I compare all of them and get the minimum. So that's the implementation I did last time. However, this is out time limit exceeded. So the time complexity was in line 14 outer loop, it should take O of n. And inner loop in line 20, O of n. And in line 27 and to line 30 for these heap operations, log k for each. So multiplying all of them, the time complexity should be n squared log k. And in this video, I will optimize this to n log k. Yeah, I actually read the editorial and also read my solution, which I came up last year. And and now I remember that solution. Yeah, I was smarter last year. Being said, let me get started from the explanation. So I will be given quality and also wage. And wage should be expected wage. So let's say this is like this. And what we do from here is I will calculate the expected wage per quality. And it should be, oh, let me make it bigger like this. So this person, the first person, expect actually expect for um payment unit for salary unit per sorry, enemy. Expected wage quality. No, wait, this should be quality and this should be wage, expected wage. So in this way, the first person actually, this person is actually expecting for pay unit per one quality. And for the second one, he's actually expecting 5 pay unit per quality. And the first one, no, second one, sorry, third person, he expect to pay unit per quality. That's his expectation. And those being said, I will say I will pick 2 workers. Yeah. So in my previous approach, first way I picked this person. This pay rate per quality. 4, and try to find k minus 1 workers in which yeah sorry I choose this 4 payment quality payment per quality rate. Then I calculate all the other salary. So when I choose this should be 20 and 40. Yeah. Then I calculated all of them and I guess the salary. I would choose 2 workers, 28 and 20. Then 48 is the minimum worker when I choose this rate 4. So instead of this, what I can do is I will sort the this rate. Yeah. Expected wage per quality in ascending order. Wait a minute, 2, 4, 5, 5, 7, 5. Then 10, 28, 25. Okay. Then from here, what I can do is say I choose rate with 2. Then I actually can pay for only this first person, 10. So I cannot choose enough people it under K. But when I decide to choose the rate 4, if I choose the rate 4, it means that I can satisfy the expectation for these 2 first workers. So I will take a look at two workers, and out of these two workers, I will choose the minimum work minimum minute to pay meant no, so minute to actual salaries. Then if I decide to set the expectation, um, I mean rate with 5, in that case, these three workers are satisfied. So I can choose two workers from these three workers, and that's it. So in this way, I don't have to create a heap all the time for each picked up, fixed person, person X. So in this way, the iteration should be n times. And also for each, I have to push only one new worker to the heap. And also maybe I have to pop out one worker from the heap. Each of them should take log k. So in total, it should take over log n log k time. Yeah, so that's it. Okay. So, yep. Let me work on it. So let me work on the implementation with this. So, let me quickly outlist the solution. So for each worker, sort by yeah. So this is it. Okay. So that being said, I will start my implementation. So first thing I will do is sort the worker by weight, quality, and expectation. Okay, so so in this way, workers are now sorted by the rate, expected wage per quality, and yeah, each element is the tuple of quality and expected wage. Okay. Then from here, I will pick one. So assume. Okay, so with those prepared, I will do the iteration. So, oh, sorry, I actually don't need it. So now for this person, expected wage is this and quality is this. So I will push this person into the heap. And all I need to do now is only quality in the heap. I mean worker pool. Because um deciding the rate, the salary is decided by the um salary, yeah, the rate I determine times the quality. Expected salary is doesn't matter, but it guarantees that it meets it. I mean, actual offer is higher than expected wage. That being said, let me rename this to qualities heap. So I push this into the quality heap, and then so if the heap is bigger than k, I will pop it out. And one thing I have to take care is heap q dot heap push and heap, sorry, heap q dot heap push and heap q dot heap pop are used as mini heap in Python. And I don't have any option to work it as make it work as the mini heap. So as a workaround, what I can do is when I push the element, I will input the negative number of that element. In that way, the biggest number is popped first as the biggest negative number. Okay. So now I come back to line 34, and here what I do is guess the sum of the wage. So it should be now quality. Oh, so sorry. So for this person X, I can say the actual wage is expected wage, and I can calculate the rate with expected wage bar divided by quality. And using this rate, I can calculate the total wage as this. I guess the sum of the quality and multiply -1 because all of the element in the heap is -1, negative actual number. And then I calculate multiply by rate, and I get the total wage. And because I try to get the global total wage across the for loop, I will do it in this way. So, yep, that's it. One thing I have to take care is, wait a minute. Yeah. Oh, one thing I try to take care is if I can always pick k numbers and this return is not infinity when it return. I can confirm it from here. N is larger than k, so this return is not mass infinity. It's guaranteed. Okay, so let me execute my code. Or okay, maybe I will quickly walk through my code. The first three in line 25, I initiate the workers list, whose each element is quality and expected wage of each worker. Then I will sort it by the expected wage per quality rate. Then in line 30, I initiate the heap internal list. Then in line 31, I has the iteration. So each worker from the quality and expected wage, I can choose the rate for this, Yeah. Actual salary per quality rate at this moment, at this step. And it is guaranteed that all the workers who, who are before this worker in the list has a lower rate, expected salary rate. I can choose K from any of them. So for that, I will use the max heap. So I will push the user to the heap, user's quality to the heap. And if the size exceeds K, I pop out the highest quality person. Because highest quality person is paid the most under the same rate. Then in line 38, I calculate the total wage and I update the return variable with that. And then finally, I will return that global minimum wage variable in line 42. Okay, good. Let me submit my code. Oh, so I have to zip it. Yeah. So this should be key option. Sorry, this should be some of the qualities heap. So it's wrong. Let me work it out. So firstly, I will we'll take a look at the workers list. Then I'm sorry, they are sorted by the expected wage rate. So it looks good so far. And in line 37 or line 40. Oh, I forgot to do something. So in line 40, this should do there are enough workers in the pool. So in the first K-1 steps, the worker pool, qualities heap, is not big enough. In that case, I cannot calculate the total wage from them because there aren't enough workers. Okay, so let me execute my code with this. Good, accepted. Okay, so now I will clean up the code and I will submit it. Okay, it's accepted. So let me quickly wrap up. So today in this video, I solved this question again. Minimum cost to hire K workers. And in this solution, I made the optimization from my previous video. That optimization is that I sort the workers by expected wage per quality. Then I iterate them. And for each worker, I sorted the workers with the expected wage per quality rate. So as I go through the list of workers, the actual salary per quality rate is increases. And for each step, I will choose k workers who are from all the workers before that person and that person. And I guess the minimum total wage for each step. Then I get the, yeah, with those total wage per step per person X, I get the global total wage minimum. Then I return it. So that's it. Okay, so in this way, the time compressor should be in line 31. This should be all of n steps. And in line 34 and 36, this is O log k, because heap operation takes log k, basically. So the time complexity should be n log k, and space complexity should be, it takes the new list workers whose size is n, and also I need the heap whose size is up to k, and because n is larger than k, it should be O over n. Okay, so with this being said, let me finish my today's video. Thank you so much.